let's talk about the unsung heroes of every network, transport technologies. They are what makes your data move swiftly and securely, whether it is a simple office file or a global video stream. In this video, we will break down the transport tech powering the modern networks, explaining how they work and how to design them right. By the end, you will know your way around layer 2 and layer 3 technologies and how to build networks that are fast, scalable and bulletproof. What are core transport technologies? At the heart of every network is a transport mechanism that carries your data from point A to point B. These operates at OSI layer 2 and layer 3. Layer 2, think local. It handles connection between directly linked devices with technologies like Ethernet and VLANs. Layer 3, think global. It routes data across networks using protocols like IP and BGP. Each layer has its role, strength and ideal use cases. Get the transport layer right and your data flows smoothly with speed, security and minimal delay. Layer 2 transport technologies. These are your go-to for LANs or directly connected system. No routing needed, just fast, efficient data delivery. Ethernet, the MVP of layer 2. It's fast, reliable and everywhere. Scales from 10 megabits to 400 gigabits per second. Works in homes, offices and massive data centers. Affordable and easy to deploy. VLANs or virtual LANs. Segment your network, boost performance and add a layer of security. Separate guest and employee traffic. Cut down broadcast noise for better efficiency. VPLS, virtual private LAN service. Take your LAN global. VPLS creates a virtual layer 2 network over the WAN. Perfect for businesses with offices in multiple cities. Simple LAN-like setup across cities. Supports full mesh communication, but scalability can be tricky. VXLAN, virtual extensible LAN. The cloud-native layer 2 solution designed for huge multi-tenant environments. Supports 6 million IDs versus VLANs is only 4096. Scales effortlessly for large data centers. Perfect for cloud and virtualized setups. Layer 3 transport technologies. Now we step into wide area territory. These technologies route data between networks using a smart path selection and powerful protocols. IP, Internet Protocol. The base layer of the Internet. IPv4 classic 32-bit. IPv6 modern 128-bit virtually infinite addresses. MPLS, multi-protocol label switching. Think of it as express lanes for data. Instead of IP addresses, MPLS uses labels to route traffic quickly. Traffic engineering made easy. Supports QoS for voice over IP, video and more. Highly scalable for big enterprise and service provider networks. EVPN, Ethernet VPN. An MPLS upgrade that blends layer 2 and layer 3. Great for modern data centers. Delivers both Ethernet simplicity and MPLS power. Handles multiple tenancy and failover with ease. Segment routing, the next gen routing tech. Routes are encoded into packets. No need for complex protocol. Streamline operation, dynamic path selection, built for scale and speed. Design consideration. For transport layers, here is what to keep in mind when building your transport layer. Scalability. Build with growth in mind. Module design makes scaling easier. Redundancy and high availability. Design for failure. Redundant links and devices keep your network running even when things break. Performance. Prioritize low latency for sensitive apps. Use tech like MPLS or segment routing to fine-tune traffic flows. Security. Encrypt traffic. Use firewalls and access controls to secure the transport path. Cost efficiency. Get the performance you need without blowing the budget. Factor in hardware, software, and maintenance. A global enterprise network. A multinational needs secure high-speed links between offices. Solution: MPLS WAN plus VPLS for seamless layer 2 across sites. Cloud service provider. Thousands of customers, isolated, high availability infrastructure. Solution: VXLAN for tenant isolation plus EVPN for scalable, resilient layer 2 and 3 connectivity. Challenges in a transport design. Complexity. Technologies like MPLS or segment routing can be tricky. Automation helps. Legacy systems. Modern tech must work with older infrastructure. Hybrid models like MPLS plus SD-WAN ease the transition. Security risk. Without a proper control, the transport layer is vulnerable. Use best practices, encryption, firewalls, and audits. Future trends in transport. SDN. Software-defined networking. Centralized control, simplify management. Automation and AI. Smarter networks that self-optimize, troubleshoot, and adapt. Convergence. Mixing old and new MPLS and SD-WAN often work side by side for flexible, reliable connectivity. Best practice recap. Align with business goals. Design for reliability with redundancy. Stick to standards for easy integration. Continuously monitor and optimize. Always plan for future growth. Transport technologies are the engine behind the modern networks, from Ethernet to segment routing. Each piece plays a role in building networks that are fast, secure, and ready for anything. Whether you are connecting a local office or a global cloud, the right transport tech makes all the difference. Thanks for watching, and don't miss our next video on building intelligent network architecture. See you next time.